All right, so we need to figure out on number 22 and 6.1 is f of x is 4x to the 7th minus 3x to the 5th, even, odd, neither, or both. Both should be an easy dismissal. Do you guys know why both is an easy dismissal? Okay. So what does odd mean?
Negative f of x equals f of negative x.
Negative f of x equals f of negative x. Okay? Cool. What does even mean?
F of negative x equals f of x.
F of negative x equals f of x? Okay, so notice the key thing that you're checking in both of these, right? You really should be checking f of negative x, right? So neither would just mean that neither of these things is true, right? What would both mean?
That f of negative f of x equals f of x.
Yeah, so both is easy dismissal, because that would mean that negative f of x should equal f of negative x, right? From being odd. But f of negative x is also f of x, right? You guys see that? Which would mean that negative f of x equals f of x. Which means what? Yeah, good. The whole thing has to be 0. You guys see that? So the only function that's both even and odd and defined on all the real numbers at least is 0. You guys see that? We could make a few more if we allowed it to be undefined at other places, but there would be some derivative of this. You guys see that? I don't mean that in a calculus sense, I mean that in an English sense. So both, the only function that's both is 0, so we probably don't have that one here today. So how do I check if this thing's even or odd or neither? Yeah, look at f of negative x, right? And then see what comes up. So what do you get if you plug negative x in here? Okay, 4 times negative x to the 7 minus 3 times negative x to the 5th. And negative x to the 7th is, okay, so you want to pull that negative out, right? Okay, so we got negative 4x to the 7th. That's really kind of thinking minus x to the 7th is minus x to the 7th, right? 7 negatives multiplied together, so 6 of them are going to reduce to 1, and then the other one will be left over. And for the 5, what do you got?
Plus 3x to the
Plus 3x to the 5th there. And that's again the same argument, right? Negative x to the 5th is negative x to the 5th. Okay, now what? You guys see it? Yeah, I flipped all the signs. So really you could think, okay, what if I factor a negative out of this thing? Why would I factor a negative out of this?
Because you're looking for a negative f of x.
Good. I'm looking for negative f of x. So if I can pull a negative out, I got 4x to the 7th minus 3x to the 5th in there. This junk here, right? Your 4x to the 7th minus 3x to the 5th. What's that, John? That's f of x. So this is negative f of x. Right?
Those are equal, so it's odd.
So those are equal. Check. This is odd. Good. Cool. Okay. What does it look like? Actually, that's a good question. What does it look like if it's not? Like, what would have stopped me from claiming that this thing is odd? What would I have needed to change?
One of them were even.
Yeah, if one of the powers were even, that would dark things up, right? Or actually, a factoring error on my part would dark things up, right? Like if I said, okay, when I factor that negative sign out of this, if I end up with 4x to the 7th plus 3x to the 5th, right? If I make that little factoring error, then am I right in saying that this thing is odd? No, I'd be nuts, right? You need to actually have all of f in here. Luckily, we didn't make this factoring error and thus wouldn't have this. Right? You guys see that?